I'm Professor Rad, and today we're going to talk about the commutative property. So, an operation has the commutative property if you can change the order of the values that are being operated on without changing the result of the operation. So in this video, we're going to do a few examples, kind of like an experiment to see if an operation has the commutative property or not, but we're not going to do any formal proofs or anything like that. So let's do a little experiment with addition. So if I have 10 plus 2, that means I start at 10 and I'm going to add 2 more to it. So we have 10, 11, 12. If I have 2 plus 10, that means I start at 2 and then I have to add 10 things to it. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like we have some good evidence that addition has the commutative property. I can do 10 plus 2 and 2 plus 10, and both ways I'm going to get the same answer of 12. But not everything is commutative, so let's look at subtraction here. If I have 10 things and I take 2 away, that means I'm only going to have 8 things left. Whereas if I have $2 in the bank and then I withdraw 10, well, I've withdrawn all $2 that I had and then some. So I'm overdrawn by $8. So if I do 10 minus 2, I get a positive 8. But if I do a 2 minus 10, I get a negative 8. So that means subtraction is not commutative. So addition appears to be commutative, but subtraction appears not to be. So let's see if we can find any other operations that might appear to be commutative. Let's take a look at, I've got a bunch here, wow. So let's take a look at multiplication. 10 times 2. So that means you have 10 objects in a group, and you've got 2 groups of them. So total, you would have 20 objects. If I have 2 times 10, that means I'm going to have 10 groups, each containing 2 objects. So let's count by 2's 10 times. So we'd have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So if we had 10 times 2, we get 20. And if we have 2 times 10, we also get 20. So it looks like multiplication is maybe commutative as well. Okay, what about division? So if I have 10 things and I try to split them up evenly amongst 2 people, each person is going to get 5 items, since 10 divided by 2 is 5. But if I have 2 items and I try to split them amongst 10 people, well, everyone's not going to get 5 items that way, will they? Let's try. So if I have 2 divided by 10, yeah, I get 0.2. So very clearly, division is not going to be commutative. How about exponents? So here I have 10 raised to the power of 2. So that's going to mean 10 times 10, which is 100. 2 to the 10th power, oh golly, that's going to mean multiplying 2 10 times. So let's bring our friend back here to help us out. Let's do 2 to the 10th power, and that's going to give us 1024. So what do you think? Exponents, not commutative. If I change the number in the base and the exponent, I end up getting different answers. So exponents, nah, that's not commutative. How about radicals? So if I'm looking at a radical, here I have an index of 2 and a radicand of 10. And if I flip them, that would give me an index of 10 and a radicand of 2. I have a suspicion this isn't going to work well. So let's try the square root of 10. About 3.162. All right, and now let's try the 10th root of 2. So bring this over here. The 10th root of 2, it's not 3.16, 1.07. So it looks like with radicals, that is also not commutative. So if we look at our summary here, it looks like we can switch the order if we're adding and if we're multiplying, but not if we're subtracting or dividing or doing exponents or doing radicals. So that's going to lead us to Theorem 1. Addition and multiplication are commutative operations. Subtraction, division, exponents, and radicals are not. So in example 7, this is another way that you'll often be asked questions about properties. So here we're going to be asked to identify whether each equation indicates the commutative property. To do this, you want to see what's different. It's like a spot the difference kind of game between the left-hand side and the right-hand side. If the order of the numbers is different and it's addition or subtraction, then it's going to demonstrate the commutative property. So here, for example, we have 5 plus 8, and then we have 8 plus 5. So we're adding, and the 5 and 8 have switched orders. So this one does show the commutative property. Now this one is a little weird. We have 10 plus 3 times 4, and on the right we have 3 plus 10 times 4. So if I look at what's different, it looks like we had 10 plus 3 on the left and 3 plus 10 on the right. So it kind of looks like we've changed our order of adding, but the problem is we've got this multiplication here. And if we were to follow our order of operations, we would likely get something different on each side. Let's try. So here, 3 times 4 is 12, and 12 plus 10 is 22. And on the right, 4 times 10 is 40, plus 3 is 43. So it looks like having that multiplication is going to prevent us from being able to commute the addition, because the multiplication is a more powerful operation. So no, this does not demonstrate commutation. Okay, let's take a look at part C. Here we have 10 plus 3 times 4, and on the right we have 10 plus 4 times 3. So what has changed? On the left-hand side, we've got 3 times 4, and on the right-hand side, we have 4 times 3. So we have a similar situation in part B, but what has changed is even though this plus is different, what has changed is that multiplication takes priority over addition. So the order of the multiplying changing here is okay. Let's see if we get the same answer. 3 times 4 is 12, and 12 plus 10 is 22. 4 times 3 is 12, and 12 plus 10 is 22. So the balance is maintained in the equation, and here the 3 and the 4 changed order, and the 4 and the 3 changed order. So yes, this one does show the commutative property. So we can see this is a little bit sneaky, trying to find whether or not the property is demonstrated based off of our order of operations and how that impacts the property's use. Okay, let's take a look at part D. In part D, we have 10 plus 3 in parentheses times 4. And on the right, we have 4 times 10 plus 3. Now, when I look at this, what I notice is that both of the things that are in the sets of parentheses are the same. They're both 10 plus 3. So the way that I envision this in my mind is I've got thing times 4. So thing times 4 is equal to 4 times thing. And in each case, those things are the same. So this is a yes. You can change the order when you multiply. Thing times 4 is the same as 4 times thing. Okay, let's try part E. It looks kind of similar because it's got those parentheses. So here we have 10 times, and then in parentheses, 3 times 4. On the right-hand side, we have 10 times 3, and then times 4. This one does not show the commutative property. Here's why. If I look at what the thing is on the left, 3 times 4, and I compare it to the thing on the right, 10 times 3, they're different. These are different things. So what has changed is not the order, but something else has changed between the two sides. And in fact, if I look at the numbers themselves, 10, 3, 4, 10, 3, 4, the order hasn't changed. In order to be the commutative property, the order has to change between the two sides. Okay, so let's take a look at this last one. We have 10 times 3 times 4, and 10 times 4 times 3. So I notice in this case, those parentheses are almost the same, but what's different? It looks like the order is different between the two. Here we had 3 times 4, and here we had 4 times 3. So this is kind of similar to what happened in part C, where we had priority over an operation, and here we have priority because of those parentheses. And the prioritized operation, the order is changing, and that's allowed for multiplication. So yes, this one also demonstrates the commutative property. So you can see that sometimes identifying the commutative property can be a bit tricky. What you want to look for is what is different. Has the order changed or has something else changed? And if the order of things has changed, has it impacted the result? So just a reminder, in part B, we had the order of things changing, but it impacted the result, so it was not showing commutation. Whereas in C, the order changed and it didn't impact the result. So yes, we were able to demonstrate the commutative property. So here are a few exercises for you to try to find an example of something that shows something is or is not commutative. And then for these last 4, kind of like this example we just did. In the next video, we're going to dig a little bit deeper into the commutative property and experiment with some brand new operations just to get the concept to stick a little bit more. So I hope you have a wonderful day, and I'll see you next time. Bye, everyone.